video, let us see about the Kruskals algorithm. So in the Kruskals algorithm, we construct the minimum spanning tree. So in order to construct the minimum spanning tree, first we have to remove the loops and the parallel edges in the given graph. So say that we have got two parallel edges and one loop here. So these are the two parallel edges. From A to B, it is 10 and 5. So we'll remove the edge which has got a higher cost. So let us remove the edge with the higher cost, say 10. So let us remove this. And similarly, we have the loop which is on the vertex E. So let us remove the loop. So this is the updated graph that we have after removing the parallel loop and the parallel edges and the loop. Now what's the first step in Kruskal is, first we have to arrange all the edges according to the order of their edge weight. So that is the first step. So we have to sort the edges from the low weight to the high. And in step 2, what do we do is we take the edges which has a lower weight and then we add it to the spanning tree. So if adding the edge, if it is creating a cycle, then we have to reject the edge. And then we keep on adding the edge until we reach all the vertices of the graph. So we will see the step later. So before that, let us see an example. So let us take the same graph and first step, we'll sort all the edges from the low to high. So which edges having a lower weight is the edges BD. So let us write down BD is having an edge weight of 2. Next is DE with edge weight of 2. Next AC with edge weight of 3. CD with edge weight of 3. And then BE with edge weight of 4. AB with edge weight of 5. CB with the edge weight of 6. AF with the edge weight of 7. And FC with the edge weight of 8. So now let us construct the spanning tree for the given graph. So what's the step 2? We have to take the edge with the lowest weight and we have to add it to the spanning tree. So the edge with lowest weight is BD, then DE. But when we form, we should see to it that it does not form a cycle. So let us first draw only the vertex of the graph. So the vertex of the graph, we'll draw it first. So it is just node A. So here we have got node F. So let us just draw this nodes. So node F, node A, node C, node B, node D and node E. Now let us make out the connection here. So now when we make out the connection, BD, it is 2. So let us include this edge. Next is DE. So DE, let us include its edge weight is 2. Next is AC. So AC edge weight is 3. Now CD. CD, the edge weight is 3. Now let us include BE. Now when we try to include BE, it is forming what? The cycle. So we are not supposed to include this edge. So let us remove this edge. So now let us find out the next step, that is AB. So now let us see AB. So AB, it is still again it is forming the cycle. So we are not supposed to include this edge. Next is CB. So CB, let us see, even if we make out this, it is forming the cycle. So we are not supposed to include this. Next is AF. So AF, it is 8. So AF, it is 7. So let us include this edge. Now let us see FC. FC, it cannot be included because it forms a cycle. And now we see that all the vertices of this graph are being connected and this is the minimum spanning tree. So the total cost of the spanning tree is 7 plus 3 plus 3 plus 2 plus 2. So the total cost is going to be 10, 15 and plus 2, it is 70. So the time complexity for this Kruskals algorithm will be order of E log E. So what is this order of E log E? So the time complexity of this Kruskals algorithm is order of E log E. So E is the number of edges. So this complexity is because that this algorithm mainly uses the priority queue, right? So we arrange the edges from the lower weight to the higher weight and is based on the priority queue. So the time complexity when we use the priority queue is order of log E. Now let us see the steps for implementing the Kruskals algorithm. So as I mentioned, first we have to sort all the edges from the lower weight to height, and so we have to sort all the edges which is having a lower weight to the higher weight edges, and then we take the edge with the lower weight and then we add it to the spanning tree. So when we add, we have to check out whether it creates a cycle. If it creates a cycle, then we have to reject the edge. So as if we have done when AB, when we are trying to include this edge, if we include, it will form a cycle. So we have rejected it. And then we keep on adding the edges until we reach all the vertices of the graph. So this is how the Kruskals algorithm works. So hope you have understood. That's Prim's algorithm, what you have watched in the last video, and the Kruskals algorithm. Both are used to construct the minimum spanning tree for a given graph.